So we've got our vocab for this lesson. We're going to be using this. The next part of this video is writing equations of parallel and perpendicular lines. And so it's helpful to have point slope form. And I rearrange point slope form a little bit from the quote real way. You may, if you've never had me before, remember seeing point slope form like this. This is the real point slope form. I like rearranging it by adding the y1. It makes it easier to read in, I think, two ways. One, you've got your ordered pair, x1, y1 in order, xy, whereas in the real point slope form, you see the y first and then the x, so it's backwards. That throws a lot of students off. And the other reason that I like it is it works with my asylum analogy. So inside the asylum, in the parentheses, grouped with the x, it's the opposite of what you think. So when you pull that ordered pair out, it's a positive x1. And then here, outside the asylum, it's normal, so it stays whatever you see sitting there. So I think it makes it a little bit easier to read. So that's why I rearrange the point slope form. So that's the form we'll be using. And then as, again, a refresher, parallel lines have the same slope, the same rate of change, but different y-intercepts, so they will never intersect. Perpendicular lines, their slopes are opposite, meaning one positive, one negative, and reciprocal. Remember, that means you're flipping it. So for example, if you have a slope that's an integer, like 2, the reciprocal would be 1 over 2. And the opposite reciprocal would be negative 1/2. So that would be an example of perpendicular slopes. Starting first of all, just by refreshing our memory on how to write the equation of a line given 2 points. So first we need our slope. Slope, remember, is, for those that don't, y2 minus y1 over x2 minus x1. Change in y over change in x. In this case, with the slope formula, it does not matter which point you call y2 and x2. What matters is that these two are from the same ordered pair, and these are from the same ordered pair. If you flip them around, then you'll get the wrong sign on your slope. So I'm going to start with 4, 1 being my x2, y2. So I'm going to do 1 minus negative 3 over 4 minus 2, and we'll get 4 over 2 or 2. Once you have your slope, use point slope formula, and you can choose either point you want to substitute in. So as a reminder, this is our point slope formula. So I'm just going to choose the first point. So I'm going to substitute my slope for m. The x, y are your variables. The x1, y1 are your coordinates. So I'm going to substitute the 4 for x going into the asylum, so it becomes negative, and the 1 for y, which stays outside, so it stays positive. Once you have it substituted into point slope form, just distribute your slope and simplify. So we get 2x minus 8 plus 1. Combining those like terms, our equation is y equals 2x minus 7. All right, last example, we're going to be writing equations of parallel and perpendicular lines. And this is the same process that we just looked at. We just need to determine the slope and the point. So when it's a line parallel, the slope will stay the same. So I like to specifically write down the slope that I'm using to organize before I substitute into the equation. It's also helpful if you don't have the point slope form memorized to jot it down again, and then you're just directly substituting into the equation. So we have a slope of negative 2. We have an x-coordinate of negative 1, but when it goes into the asylum, it becomes a positive 1. And then our y is a positive 3, staying outside the asylum. Finally, putting it into slope-intercept form, we're going to distribute our slope and combine those like terms. And finally, an example of a line perpendicular. So I'm going to write down that ordered pair again, because I already forgot it. Negative 1, 3. All right, so again, writing down, I like writing down my perpendicular slope. Remember that upside down T is the symbol for perpendicular. It's opposite, so my slope will be positive, and the reciprocal of 2 is 1/2. Writing down point slope form and substituting in, my slope is 1/2. My y is -1, it goes into the asylum, becomes positive. Sorry, my x, my y stays outside and stays positive. And finally distributing that 1/2 and combining like terms, you can go ahead and leave it as 3.5. You do not have to change it into an improper fraction. And especially for the equation of a line, I would recommend not changing it to an improper fraction because that's our y-intercept. And it's going to be a whole lot easier to graph 3.5 on the y-axis than it would be to graph 7/2. We'd have to convert it back anyway. And your U-try questions.